video we are going to discuss how the data is processed inside the CPU. At the end of this video, we will see some programming tips. So we give input to the CPU, the black box here, and we'll get the output. So there is a lane called bus. All the input devices and output devices are connected to this bus, and also the internal RAM, hard disk and CPU units are connected to this bus. So the input data is traveled through this bus and goes to the RAM. The RAM reads the function and gives the function to the CPU. The CPU gives back the data to the RAM, and the data will be transferred again to the output devices. When we save some file, the data is transferred to the hard disk and stored in the permanent memory unit.
As you know, the computer only knows zeros and ones, just as numbers are binary patterns of ones and zeros. Letters are represented using zeros and ones. Since there is an overlapping between ones and zeros, the representing numbers and letters, the ASCII standards has created to map specific letters to specific numbers. Example, capital A is mapped to 65 and lowercase a is mapped to 97. Likely, 48 is mapped to the digit 0. And some functions like escape and delete are also mapped.
As time has rolled on, there are many more ways to communicate via text. Since there were enough digits in binary to represent all the various characters that could be represented by human, the Unicode standard expanded the number of bits how can be transmitted and understood by the computer. Computer scientists face the challenge when wanting to assign various skin tones to each emoji to allow the communication to be further personalized. In this case, creators and contribution of emoji decided to change the internal bits which could change the structure and tone of the emojis. The program you see here is a basic C program which stores the user input and prints the greeting for the user. Now after pre-processing, the code somewhat looks like this. The header file becomes converted and changed something like this long line. Then this code is compiled and changed into the assembly code. Then the assembly code changes into the machine code. And finally, the header file, binary code and the code were linked and look like this. When you run this, the program runs and gives you the following output you want.
So for pro tip, we are going to discuss about debugging. The process of finding and fixing errors or bugs in a source code is known as debugging. So to demonstrate this, I am using a C code. This is a basic C code to find the sum of two numbers. So to run a debugger, you should compile the program beforehand. Then you can see a red dot here. This is a breaking point for a debugger, which means we are indicating the debugger to run from here. So I am going to run my debugger. And a new window will be opened in the place of Explorer. So when a debugger starts, you can see all the variable values here, and you can see this new bar. This is to step forward, to go to the next step or next function you have given to the system. This is to go inside a block and run each condition, check each condition whether it's working or not. This is called step into and this is called step over. And this red box is used to stop the debugger. So I have kept my breaking point here.
And as you give the input, the variable values also changes. Now let's see how does it all go. I hope you understand how does this debugger work. Thank you. Happy coding.